show you how to form the Z-bus matrix or impedance matrix. I will be following this book Power System Analysis by Hadi Sadat. And in chapter 9, in article number 9.5, you will see the article that is called Algorithm for Formation of the BUS Impedance Matrix. So here in 9.5 in page 369. So let me just take you there. So this is the 9.5 article, Algorithm for Formation of the BUS Impedance Matrix. They are actually following this structure or this circuit right here. There are three nodes, 1, 2 and 3. 3 is connected to the load, and there 1 and 2 are connected to the reference bus. 3 is connected to the ground actually with the load. And so here, if you actually see here, 1, 2, 3 is our 3 node and 0 is our reference node. 1 and 2 are connected to the reference node, but 3 is not connected to the reference node, so there is no direct line or edge between 0 and 3. So we just representing that circuit like this with the node, and here you are seeing that 3 branches of this node, because if you actually see the equation, the branch will be equal to n minus 1. And these two dashed lines represent the co-tree, and branches are also called the tree, so we can actually call them like that. The element of a tree are called branches. Here branch will be equal to n minus 1. So n is our number of node. With the reference node there is our 4 node, so 4 minus 1, 3 is our branch number. And here there are total 5 edges, so from the 5 edge, if we minus the 3 branch, we will get the number of link or co-tree, that is 2. So we are actually getting this 2 co-tree between 1 and 2 and 2 and 3 by the dot line, dash line. So here with the 0, the 1 is connected. There we are actually getting a new node here. If we get a new node, that will be actually called a tree. And here we are also getting a new node if we connect 0 and 2. So after this, we are actually, if we connect 1 and 2, we are not getting any new node because we already have 1 and 2 separate node by connecting it with the 0 reference node. So here this is a co-tree. Same will happen if we actually connect 1 and 3. We are getting a new node at 3. So 1, 3 is actually a branch, but if we connect 2 and 3, we already have the 2 and 3 node. So in between them, we are not getting a new node, that will be co-tree. I think you already know this, so I will just go to the process directly, or the algorithm. So here you will see that all the rules are actually summarized here. I will follow this step by step, so you can actually find this anywhere if you actually download the PDF. So here is our Z-bus matrix. The matrix element will be actually positioned on the diagonal position. So here the addition of a tree branch, and then if we want to add a new bus to an old bus, the process is actually explained here, like m into m is our matrix. If we want to add another one, then the order of the matrix will be m plus 1 into m plus 1. So one by one we will add the values, and the matrix will get bigger until all the nodes are done. So that is how we are getting it. You can see this, that the value is actually same on the new row and column, the one we actually want to add it with. If we want to add it with number 1 row or number 1 a particular position, we will select that row and column, and then we will add it at the end of the column and row. And here also the co-tree, the addition of co-tree between 2 existing buses. Here you can see the difference is taken in the new column here between these two. Also in the last row here, the new row that is added, that is also taking the difference. And here the ZLL is that impedance of that position, that is actually calculated by using that equation. And here, and this is our old bus now. After forming that new bus, this one is our old bus, so this one is our new bus now. So here if we want to find the final bus, we need to actually minus this term from the old bus. So here del Z, and del z transform. This is the del z. This is actually nothing but the column that is actually found inside our new z bus, this part, if you see, and the transpose of this z del z is actually del z t, that is represented here. So if we actually do this, then we will get the final result of our z bus. So now we will just follow this circuit to actually calculate the value by writing the program in MATLAB. So here you can see the exactly same image we have seen previously. So let's start writing our code. So first, the common thing, CLC and clear all. Then we will display a message, formation of BUS matrix, and then we will take an input for the number of node. Just simply use the input function, and inside it we'll write the string enter number of node including the reference node. That means we need to add 1 with the number of actual node, and then the link. This will be another input. Enter number of code tree. You can directly take the code tree as input, or you can actually give the number of edge as input, and you can calculate by using the equation like number of edge minus number of branch will be equal to link. And then here z and del both are two matrix, so here we are actually initializing them with 0. We are using zeros function to initialize them. And if we run this code, you will actually understand this properly. Here the node is 4 and code tree is 2. Then Z will be a 3 by 3 matrix, and the del will be a column matrix which will have 3 rows. So after this we will just add semicolon. We don't need to actually see them. And here we are creating a for loop first. Okay, let me just write the main code first. I will write the variable later for loop. So inside a variable we are taking another input, and that will be with which node you want to add a new branch. So there can be a new branch with the reference node, or we can actually create a new branch with the help of another node which is not a reference node. Like we can connect 1 and 3. So here after taking that input, there can be two conditions again. One is if a is equal 0, that means we are connecting it with the reference node. Then we will take the input and put it inside z of I and I. And that is because whenever we connect a node with the reference node, we need to put that value inside the diagonal, inside the matrix along the diagonal, and that is why we are actually doing this. If we want to connect 1 with the reference node, then z11 will have the value, and if it is a 2 with the reference node, then z22 will get the value and put it inside that position in the matrix, Z matrix. So here I'm just writing the input, and we are using strcat to actually get both string and number, and for number we are using integer to str, integer to string, int to str. We need to write it like this, and then inside the parenthesis we will give the parameter. This parameter will be I and I, because this is actually our diagonal element. And then we will put a break, and inside the else condition we will write another if else condition, because if a is not equal 0, then there can be again two conditions. One, if I and j are equal, then we will write j of ij equal z of aa plus z of aa is, right now it is 0 because we are just starting. We have already given 0 for all the values when we initialized the z matrix with the zeros function. So here we are just doing this, and when the for loop will run, there will be a value for z of AA, and that value will be added every time the loop actually run. So here we are getting that value here and then putting that inside the z of ij position, and this will be done when I and j are equal, and there will be another condition when I and j will not be equal. And inside this we need to write A, and in the second one I. And for the else condition you need to write these two lines. Just simply assign them if I and j are not equal. Then after this we will just put the Z matrix inside a new matrix that is called Z old. We will use this matrix for our next for loop. So here inside this for loop we will write k equal 1, and it will be incremented by 1 till link. We are just writing the code now for adding a link or cotree. So here we will display a message before taking the input. So if we want to add a cotree, we need two nodes. Between two nodes we need to create a cotree or link a cotree. So here enter the node x and y where you want to add cotree. So x will be equal to input, and here we need to write x equal, we will take the input like this, and then we need to take input for y. So these are the two number of nodes between which we will create the cotree, and here we are taking the input value for the impedance of that xy position. So z of xy will be equal to, then we will take the input normally, and inside this integer to string parameter, here we need to give them properly. Okay, this will be integer. So here integer to str, the first one will be x and then second one will be y. So we have taken the input. Now we need to calculate the z of nn, that was actually zll inside the algorithm. Here we have actually seen that there is an equation for getting this value, so we will get this value by using this. So this small z pq and the capital Z pq. The small z pq is actually this zx of y, sorry, zxy, that is actually the self impedance, and the small z of xy, that will be the value from our matrix in this code. So 2 into z of xy, and after this, so here we will run another for loop, and this time the parameter will be j from 1 to n minus 1, and for this we will create our del matrix. For creating that, you can actually see that whenever we want to do this, we need to find the difference between the two nodes where we want to actually add the link. So here if we want to add between p and q, you can see that we are actually getting the difference between p and q for both row and column. So here first we are doing this for z, n and j. That means we are actually fixing the row and just changing the column. So here the parameter will be like this: z of y comma j, and then x comma j. Then again z of, okay, let me write this, then I'm just giving parameter here j comma 1, because this one is actually our, sorry, n, this one is our column matrix, so the column will be fixed. So n is a fixed value, so here we are fixing the column and only the row will vary with the for loop. So after this we will create our del matrix here. So del matrix is also a column matrix, and here we are just putting that value of z of j comma n inside the del. Here you can see this is the column matrix. So here we are just putting z of j comma n inside the del matrix. And after this we need to create the variable m. Here this portion is actually the m, del z into del z transpose divided by z of l. So here we need to multiply two things and divide by z of ll. Here z of ll is the z of nn for us, and here the matrix is del and del transpose. So here now z new will be found by differentiating these two, by getting the difference between this z old and m. And here the z old will be z new. Now after saving that value we just need to assign them, and this loop will continue for the number of link we have actually given as input in the first line, in the second input. And after this we need to just do this. Now display a message, the impedance matrix or the ZBus matrix, then show the matrix. That will be our Z new. Okay, now let's check again if the loop has been ended properly or not, and run it. Okay, there is an error. Okay, I have not actually given the parameter inside the for loop here. So let me do this. I will be equal to 1 and it will be till n minus 1. There will be another for loop that will be after taking a as input. That will be for the variable j. J will be equal 1 incremented by 1 till n minus 1. And this will also end before we have ended our first for loop. So here is our if condition end, and there we will end the for loop. There you go. Now everything is okay. So let's run this again. And here the number of node is 4, then cotree is 2. Let me just get the value from this part. So we are actually adding with node 0, so Z11. Let me just match them with the answer. Okay, there is some error here. The answer does not match with this. Okay, here we have actually given 1 and 2 and 1 and 3, but if you actually check the image again, here they actually gave 1 and 3, but inside this you can see there is a link between 1 and 2 and 2 and 3, not between the 1 and 3 like they have written there. So there is a mistake. Let me give the input again. Now the value is actually okay. If you match them properly, you will see that everything is exactly same as the ZBus matrix given in the book.